Title: Weather Protection Design Strategies for Outdoor Elevators. When people talk about outdoor elevators, they often ask one simple question: can the elevator handle rain and bad weather? That is an important question. But for outdoor elevator projects, weather protection is not just about adding waterproof parts or doing more maintenance later. Effective weather protection should begin at the design stage. Many weather-related elevator problems can be traced back to early planning decisions, such as shaft configuration, enclosure selection, drainage design, component protection levels, material selection, and how the elevator connects with the building. A reliable outdoor elevator is not protected by one single feature. It is protected by a complete system design. An outdoor elevator works in a very different environment from an indoor elevator. It may face rain, wind, humidity, dust, ultraviolet exposure, temperature changes, and in some projects, coastal salt air or industrial pollution. These conditions can affect electrical components, guide rails, door systems, shaft structures, sensors, switches, cables, and control equipment. That is why outdoor elevator planning must be based on local climate, building conditions, traffic demand, and long-term maintenance access. The goal is not only to install the elevator, the goal is to make sure the system remains safe, reliable, and maintainable throughout its life cycle. The outdoor elevator shaft is the first line of defense against environmental exposure. A poorly protected shaft can allow water, wind, dust, and temperature changes to reach sensitive components. Over time, this can increase maintenance requirements and reduce system reliability. When designing an outdoor elevator shaft, project teams should evaluate wind exposure, rainwater management, structural loading, maintenance access, building facade integration, and future modernization flexibility. Different projects may use different shaft types. Some projects use steel structures. Some use aluminum framed systems. Some use reinforced concrete, some use glass-supported configurations. For outdoor panoramic elevators or scenic elevators, glass shafts can provide strong visual value, but they also require additional planning for solar heat gain, wind loading, and weather sealing. For industrial projects or transportation infrastructure, steel outdoor elevator shaft solutions may provide better structural robustness and easier maintenance access. The right shaft design depends on the project environment. Not appearance alone, an outdoor elevator enclosure helps create a more controlled operating environment around the elevator system. Some exterior elevator installations are fully enclosed. Others use semi-enclosed designs that balance weather protection, aesthetics, and project cost. Common enclosure strategies include full glass enclosures, steel-framed enclosures, hybrid glass and steel systems, and architectural facade, integrated enclosures. For existing building retrofits, the enclosure is especially important. It must protect the elevator, while also fitting the building structure and appearance. A good enclosure does not only protect the elevator from rain. It also helps manage wind, dust, temperature fluctuation, and maintenance access. Water management is one of the most important parts of elevator weatherproofing. Weather protection is not only about blocking water, it is also about controlling where water goes after it reaches the shaft. Outdoor elevator pits, shaft bases, and landing interfaces should be designed to prevent standing water from collecting around important equipment. Effective drainage strategies may include pit drainage systems, surface water diversion, waterproof ceiling details, condensation management, and elevated equipment mounting locations. This is especially important in regions with seasonal storms or heavy rainfall. Drainage capacity should be evaluated during planning, not after the elevator has already been installed. If drainage is ignored early, maintenance teams may face repeated water-related problems later. In some outdoor elevator projects, wind is just as important as rain. Observation towers, coastal developments, mountain attractions, and high-rise exterior elevator installations may experience wind conditions beyond normal assumptions. In these environments, weather protection may include wind monitoring devices, automated operational restrictions, structural reinforcement, enhanced guide rail support, and additional cable stabilization. These measures can help reduce wear on suspension systems and improve long-term operational reliability for outdoor scenic elevators and exposed high-rise installations. Wind protection should be included in early engineering planning. It should not be treated as an afterthought. One of the most overlooked parts of outdoor elevator weather protection is the IP protection rating of electrical components. Words like weatherproof or water-resistant sound useful, but they are too vague without actual protection levels. IP ratings show how well electrical equipment is protected against dust and water ingress. For outdoor elevator systems, different components may need different ratings. Outdoor control boxes may require IPFA to IPFA door operators. Emergency stop devices and junction boxes are commonly selected around IPFA. Outdoor sensors may require IPFA to IPFA. Limit switches in more exposed areas may require IPFA. IPFA provides resistance against dust accumulation and water jets from multiple directions. IPFA provides a higher level of dust and water protection, making it useful for many outdoor elevator components exposed to changing weather. IPFA provides temporary immersion resistance and may be used for sensors and critical field devices where water exposure is more severe. Higher protection ratings may increase initial cost, but they can also reduce weather-related failures, lower maintenance frequency, and improve life cycle performance for project owners. IP ratings should be evaluated together with component quality, spare parts continuity, and long-term service support. Material selection also affects outdoor elevator durability. Projects exposed to coastal environments, industrial pollution, strong humidity, or intense sunlight may need enhanced corrosion protection. Common protective solutions include stainless steel finishes, galvanized steel structures, powder-coated surfaces, anti-corrosion treatment systems, UV-resistant materials, and weather-resistant cable protection. A lower cost configuration may look attractive at the beginning, but if it requires frequent maintenance or early component replacement, the long-term cost may be higher. For outdoor elevator projects, life cycle cost is often more important than initial equipment price alone. Weather protection also depends on how the elevator connects with the building. Each project has different conditions. An outdoor home elevator attached to an existing residence may prioritize appearance and limited structural disruption. A hospital expansion project may prioritize reliability and continuous operation. A scenic elevator at a tourism destination may prioritize visibility while still needing wind protection, ceiling, and weather-resistant components. Important planning factors include existing building retrofit conditions, shaft space limitations, facade integration, traffic flow, structural load capacity, maintenance access, and future modernization potential. A good outdoor elevator weather protection strategy should match both the climate and the building. Weather protection for outdoor elevators is not a single product feature. It is a system-level engineering strategy. A reliable outdoor elevator depends on shaft design, enclosure selection, drainage planning, wind protection, IP-rated components, corrosion-resistant materials, building integration, and maintenance accessibility. The best time to solve outdoor elevator weather problems is before installation, during the planning and design stage. For more details, you can read the full article here. https://vitalift.com/fedor. Elevator, weather, protection.